All right, well, welcome everybody. Thank you to the combined webinar of SMPTE Philadelphia and SPE. Today we have Karl Kuhn. He's presenting on the SDI to ST2110 IP and ST2065 PTP. Karl is a principal solutions architect at Telestream. He specializes in next generation testing and measurement of the ST2110 IP, ST2059 PTP, 4K and UHD, HDR and WCG, and transmissions. He launched his career with Tektronix in 2000. Prior to Tektronix, he was the lead video test engineer for IBM in their digital video development laboratory in Bethesda, Maryland. Karl holds 3 U.S. patents and 1 Japanese patent that cover in-service testing of digital broadcast video. He's a contributing author for the 11th edition of the NAB Handbook, responsible for Chapter 2.9, covering the digital video standards and practices. Karl is a past EDRM regional governor and past SMPTE North American Solutions Director. In 2015, Karl was raised to the SMPTE Fellow. He is also a certified project management professional through PMI and George Washington University. So Karl, thank you very much for taking the time to meet with us today and present to us. Turn it over to you.
Well, thank you, Mark, and I appreciate your patience and flexibility as we have been working for the last several weeks to lock in a date to present. But like all good things, they take time, and I'll try to make it worth everybody's while. So I appreciate everybody taking time out of your very busy schedules to join us here today. And in today's world, you need to be staying current, and the only way to stay current is investing in yourself every single day. I've done this presentation for many organizations over the last period of time, and what I've learned, what I like is when people come up, back when I was doing these live, it was a whole lot easier. People would come up and say, Karl, that was a great presentation. And I typically ask, well, why was it great? What did you like about it? And that's good to get feedback that way, and I ask what they didn't like. But I've actually had people tell me that Karl was very helpful. And I said, what did you learn? I learned that it's time to retire. And if that's where you are in your career, well, stay tuned, because I've been involved in video. I started in Wilson High School in West Lawn, Pennsylvania, outside of Reading, and been involved in video for many decades. I'll let you figure it out. I started in 1972. And what I've seen in the last couple of years here, this is the biggest transition that I've personally ever experienced as far as how television, how video actually works. I mean, it's still about the essence, the audio and the video, but there's major changes. So with that said, you have to stay current. You're investing in yourself every day, so good. But if you're getting near retirement, well, what I say is I do technology seminars. Also, I do pre-retirement seminars. So you can take this for what it's worth, but there's a lot of changes in the industry, and it's going to come. It's happening. I mean, the early adopters have adopted it, and now it's trickling down. So major station groups, major networks are all figuring out what their plan is. Some small organizations will probably avoid it as long as possible. In fact, I had this one guy telling me that he was planning on retiring when he went through this presentation. He said he's going to play along with the boss, humor the boss as long as possible when it comes down to it. In the end, he's going to say, well, good luck. I'll be fishing with my grandkids because I want nothing more to do with this. So not to scare anybody, but if you're not looking to retire, it's really time to pay attention to this. Maybe you're in the middle of something or thinking about getting into it, or maybe avoiding it as long as possible, but it is happening. So the purpose of this presentation, my focus is lessons learned and best practices, how to help you understand what you need to know. By the pain and suffering that I've seen others go through over the last few years with greenfield builds and hybrid updates and facilities, to figure out what they wish they would have asked. Because in the beginning, there were no best practices. There were no lessons learned. We were making it up as we went. But the technology has matured, or starting to mature, to the point where we actually say, here's how it's done. And I want to share with you what I've learned on how it's done. So anyway, get the marketing out of the way here. Tektronix Video is now part of Telestream. It's one big happy family now. So we have our solutions end to end. as far as what we have as far as video processing, video transmission, and testing. Wirecast down there in the bottom right, with everybody being remote, that is an unbelievably hot product. I mean, it's in triple digits as far as the growth because everybody wants to be a YouTuber or a webcaster, and that's really hot. But we have tools that go all the way from acquisition, which is what I'm going to be focusing on, all the way through the production, post-production, all the finishing, and the actual delivery over the various pipelines to the end user. I'm focusing on the bottom part there, which is tech video, which is waveform monitors. We're talking about SDI moving to the world of 2110. And what that's all about is the transition from SDI to IP, and the main tool there is the Prism. So we have good old-fashioned SDI plant. In reality, this is your grandfather's SDI plant. You can see there's a lot of connections. Everything is basically its own individual pipeline between a device. There's not a lot of sharing. There's no real multiplexing of any type of a signal. And this has served us well for the last few decades, and it's very stable. Everybody pretty much understands it. But what we're trying to figure out now is how to move to the next level, because what we're dealing with here, video is pretty much unique, where it still uses analog signals in a facility for timing. There's no other place in the data industry or any technology that I'm aware of where analog signals are pretty much used for anything. So here we are, moving into the cool world of IP. And what it's all about is trying to make sure that things are more IT-centric. Because in reality, I'm sure you've seen it in facilities, maybe you're part of it, where IT people are taking more of a leadership management role, business decision role in how a facility functions, how it works, what is needed to actually make it done. And there's a lot of simplicity here. You can see there's a whole lot less infrastructure. So cable chases and weight, as far as in a truck, an OB truck for remote, where weight is everything, they can shed a whole lot of weight. That's a beautiful thing. But simplicity brings complexity. And that's our job, to make sure we understand the complexity of this transition, because it is a major transition. It's still audio and video, and you could say, well, IP is just an interface. Well, yes, it is, but it's a whole different approach for video people to understand more of how the data industry is architected. So there's a lot to learn here. Let's move on. Well, coax. Coax, our good old friend. Signal delay through a coax is constant. There's no packets. It's a home run connection between an output and an input, and the signal flows. It runs at a fraction of the speed of light, roughly 80% of the speed of light through copper or even optical, and it's consistent. As far as if you keep your cable types the same and cable length as close as possible, within reason, your timing is pretty much going to be stable. You might have some jitter and wander if some electronic components are not stable or running too hot, or there's other hardware issues, but fundamentally, it's a very stable system. Where IP is all about sharing a pipe between a point A and a point B, and it's bidirectional. There's bidirectional communication. So what we're doing here now is we have to multiplex. Between point A and point B, you have your signals sharing a time slot. And time needs to be correlated as far as stability for precision time protocol. That's going to be a big focus of this presentation. You're going to be tired of me saying the word smooth within the next 45 minutes, I guarantee it. But smoothness is the biggest challenge that everyone faces in this transition, because you're sharing. Your PTP has to be delivered smoothly because that's the timing of your system, but it's sharing a pipeline with megabits of audio and gigabits of video. And hopefully there's no internet traffic or file uploads or downloads. That mistake has been made. You need to have a dedicated, pure 2110 network to the best of your ability, because you do not want burstiness. As you start bringing data, uploads, downloads, web searching, that is burstiness. And there's no real place for that in the business of 2110 and PTP. So lessons learned in this new world order. Getting right to the punchlines here. Continuous learning. I touched on that when we kicked things off here. You can't stop. Every day you need to learn something new or you're becoming obsolete by the day. So continuous learning. And what you're doing here is the right thing, being involved with SBE and SMPTE. A great way to get out of your bubble, because I was a lab rat at IBM for the first half of my working career. And what I learned, I had a very IBM-centric world view, which was fine. But the guy that I ended up replacing at Tektronix said, Karl, you need to get involved with SMPTE and see what's happening in the world. Of course, I drug my feet on that. I had kids in diapers, lawns to mow, and houses to paint. I had every excuse in the book until finally Rudy Niznansky, who was the guy that I worked with as far as the Tektronix contact when I was working at IBM, he said, you got to go to this meeting tonight. You really need to hear what they're having to say. I went, and I barely understood what people were talking about because he was right. I was living in an IBM bubble. So by being exposed to other people, other things, continuous learning, it's a great way. Do Google searches, share information, whatever you need to do. But SMPTE and SBE is a good way to expose yourself to something maybe you thought you had no interest in. You go there and walk out saying, wow, I'm glad I learned that. Configuration. With SDI, out went to in, and you're doing video. Out goes to in, and it's a connection. It's simple. There's configuration as far as, IP addresses for, control systems and whatnot. But as far as the actual signal itself, out goes to in, and you're doing video. In IP, it's all about configuration. Every drop down, every fill in the blank, every radio button must be correct. You can't guess. There is no guessing in the world of IP configuration. If it's right, congratulations, it will work. If it's wrong, well, it might not work. You might not get a connection. Or worst case, what you're trying to avoid is you actually impact the stability of the entire network. If you have an IP address conflict, well, you're going to have trouble right away. So you need to make sure that configuration, there's no guesswork, and it requires a network administrator to say, here's the IP address, here's the port identifications, here's the configuration that you need to do, and don't deviate from it to maintain a stable network. SFP matching. Small form factor pluggables to go in the back of a device. They're wonderful for being an interface to whatever you need to be interfacing to. But what I have seen, they need to match. There's little devices that are very fine print. You have to basically break out a magnifying glass to even see what the model number is. And that has caused some trouble because you can't have 1310 nanometers on one end and 850 nanometers on the other. You will never get a connection. It won't work. So even the physical layer, you got to make sure that things are going to work from end to end. So SFP matching is very critical. Fiber cleanliness. You don't have to worry about SDI with BNC connector cleanliness. Practically drag them through a mud puddle and they would still work. Well, fiber is not that way. It needs to be clean. Any dirt, dust, hair, grease, whatever is going to cause a problem. Maybe not right away, but signals don't usually improve with age. So you want to keep things clean, keep them out of moisture, rain, you name it, is a problem. So fiber cleanliness is now part of our everyday life. No patch panels. I realized this early in the transition. There aren't any patch panels in the world of IP. And I'm sure at least one time in your career, you troubleshot to isolate a problem, cut your network in half and start figuring out which is working and which is not. Well, there are no patch panels in the world of IP because by having the sharing of multiplexing signals, who knows what's on that connection? You can't just pop something out and move it over here and see what happens because there's audio, video, timing, ancillary data, you name it, in that connection, and you just can't do that. So you have to troubleshoot without a patch panel. Redundancy. How much redundancy is practical? How much can you afford? In OB trucks, remote trucks, there's very little redundancy because of the weight issue. They're always trying to figure out how can they slim this down and still reduce single points of failure within reason without going over 80,000 pounds. That's always the challenge of OB trucks. How much can you afford? None. Full redundancy. I've actually had people consider going with two pieces of real estate geographically separated, running two different vendors of equipment. That's a lot of redundancy, also a lot of complications. I don't know where that's going, but that's an extreme case. Data networks are not smooth. This is big because data networks have no reason to be smooth. Data networks are upload, download, then nothing happens. Well, anyone coming from the data world of IT, this is the biggest challenge they face. My son is a cybersecurity expert responsible for global network. He really has no idea how smooth his network is. Packets get there, nobody complains, everybody's happy. Well, we need a smooth network. And that is the challenge we face, because it needs to be smooth or else you're not doing video. It falls apart. Smooth and stable is the goal. That is the challenge. Okay, multi-layer IP adds another layer of abstraction. Back in the good old days, remember analog, you took out your greenie tweaker, you go clockwise, counterclockwise, you see and hear something change. It gets better, it gets worse, and you zero it out and you're good. But then we added the cliff effect with going to SDI to the digital world. Now we're adding another layer of abstraction called IP. So the analogy I like to use, I started working on cars, that were built in the 50s, 60s, and 70s. When I was a kid, they were all analog devices. Nothing is analog anywhere in the automotive world now. It's all digital. It's a rolling computer with multiplexing signals all over the place. It's the only way you can really troubleshoot a car now, unless something is gushing a fluid. You pretty much need to have tools. You need to be able to interrogate, investigate, drill into what's happening to figure out what's censored. It's the same thing in video. You need the tools to look into the signal. Switches. Big one here. Switches must be multicast capable and PTP aware. What that means, you need to be doing multicast joins. That's how a lot of things work in this world we're going to. PTP aware, what does that mean? SMPTE 2059 PTP aware. PTP aware is a hardware option that you must order. It doesn't just happen by itself. And you want to make sure all the ports that you're going to be using PTP are PTP aware for 2059. Why do I stress the 2059? There are PTP switches out there that are PTP aware, but there's IEEE 1588 PTP aware. 1588, IEEE 1588 is the umbrella PTP standard that the world uses. And the world uses PTP everywhere. For decades, for cell phone handoffs. That's how you get a smooth handoff using PTP. Robotic automation and assembly plants, like automotive world, uses PTP for orchestrating, coordinating all the robotics systems in the facility. Also, the financial world, every financial transaction gets a PTP timestamp. And this is a wonderful thing. Point to make here, if you're looking for somebody who understands PTP and can't find anybody, you might be able to find somebody from the financial industry, because there's a whole lot of people who understand PTP in the financial IT world. And some of the sharpest people I've met in the early days were hired to facilities that blew me away with their knowledge of PTP. And I said, how do you know this? And they said, oh, I've been 20 years in the financial industry. So PTP is a wonderful thing. But the thing of it is, 1588 is much slower. It only sends out packets every 2 seconds, every 1 second, as far as stability up and down your network for these packets. That's not good enough. We're special. We're video people. So we need SMPTE 2059, which is a subset of IEEE 1588 that's specific for television, because we need packets sent roughly every 4 to 8 times per second. It's a whole lot more than once or twice a second. 4 to 8 times per second is what's required for packet stability to line up the packets so you actually get a line of video. So this is a very important aspect. So make sure you're getting PTP aware switches. If you're not, you're going to have trouble. Stream captures are priceless. You need something to have in the hold. You're dealing with layers of abstraction. When in doubt, boundary clock. If you remember anything from this presentation, in the heat of battle or when you're actually designing a system, when in doubt, boundary clock. What that means is you're isolating your grand master, which is your master clock, which is locked to GPS, that's cranking out PTP packets to all your devices in your facility. You want to reduce the workload on that grand master. How that's done is a boundary clock. That isolates the grand master from having to talk to hundreds or thousands of PTP devices. So what the boundary clock does, it communicates with the grand master clock and then broadcasts, disseminates, distributes the PTP to all devices in the field that actually need it. This was not implemented in the early days. Now it's standard practice. When in doubt, boundary clock to reduce traffic off of your grand master. Non-blocking switches. This is a mistake that was done in the early days. Non-blocking switch means you have 25 gig ports, 100 gig ports, that the backplane, the actual backbone of the hardware itself, can handle whatever you want to put in and out of any port. If you have a blocking switch, you might have all this capacity as far as the ports, but the backplane can't handle it. So it just saturates and starts dropping packets. Big thing to remember, you want non-blocking architecture in your switches. System integrator is the key to your project success. I've actually had people in the early days say, oh, we're going to figure it out on our own. We never use system integrators. We have some sharp people here. I don't recommend that right now. Maybe 5 or 10 years from now when everybody has this as far as business as usual. But if this is your first venture in the IP, your system integrator is the way to go. They have some really sharp people that can bring in experience from other projects and other greenfield builds that they've been doing. Don't cut them out of the deal. Definitely want to make sure. Learn Wireshark, free utility to analyze a file, a capture of your IP stream. Test equipment is your friend. Once again, you need layers. You're looking at layers of abstraction, and test equipment is the only way you're going to see it. Embrace it, become familiar with it, make it your own tool. Become an expert at using test equipment. Keep a library of all pertinent standards because they're all new standards. Read them, put them under your pillow, and if there's any discussion going on, you're the expert. You can look it up real quick and say, yes, this complies, no, it doesn't, or yes, it complies with their interpretation of the standard. It's completely different than the entire industry implementation everybody else is using, which has been a problem. Everybody's compliant, but their interpretation is different of how all the other vendors are doing it, and you don't have interoperability. Maintain a book of knowledge. If you learn something, document it, because maybe you'll see it again, and maybe it'll happen when you're not there. So be able to share the information, document it. Getting started. Where do you start? You need a sandbox for your entire facility life cycle. I have recommended, and people have actually heeded my advice, which warms my heart, is to build a sandbox. When you say, we're going to the world of 2110 and 2059, what I would recommend doing is buying a Telestream SPG 8000A. That is your grandmaster clock. Lock it to GPS. You have a stable time source for Blackburst and PTP. Then get a Prism, which is your analyzer, which we're going to get into. And then you build your entire facility, your sandbox, between those two devices. So as you add a device, how does it behave? Does it behave? Does it work? Is it actually impacting everything else on the network? You need some safe place. As far as dragging something out of the cardboard box and say, put this on the network, we're ready to go, I think those days are over. You need to configure it, exercise it, see if it's stable enough and worthy enough to be introduced to your actual live network. You can't cut that. You can't make a shortcut on that one. You need to justify test equipment in business terms because business people, let's face it, they run the spreadsheets, and the world is a spreadsheet when it comes to any business. How do you justify test equipment? You have to be able to do it in business terms. Not we have packet jitter problems, we have loudness issues, closed caption issues, we have PTP hits. You need to say to reduce overtime, to keep us out of trouble, to keep us on the air, to reduce truck rolls, reduce customer complaints, maintain our advertising revenue. It's a business case. Every drop-down radio button must be correct. I talked about that. Finger pointing, I'm sure you've never done it. Maybe you've read about it on the interweb, but it's everywhere. It is rampant because nobody knows. Everybody's finger pointing. And I've been involved with finger pointing disputes that have gone on for weeks. Lawyers were getting involved. In the early days, nobody bought test equipment because they didn't know what they were doing and didn't order it. I come in with a Telestream Prism, and in half a day, I say, here's what's right, here's what's wrong, this vendor has a problem. You can't guess your way through this. You can reboot a few times, but you can only go so far. You need to drill the abstraction layers. It's a multi-layer IT stack, the 7-layer ISO stack. You got to see what's happening. Monitor your facility like an intensive care ward, which means, in a medical analogy, you're responsible for the life and death of your facility. Well, analog communicates with you one-to-one. The quality of service is the quality of experience. Well, we're totally removed from that. You can have all kinds of quality of service issues that don't manifest themselves in any way to quality of experience. Until it gets so bad, then things fall apart. So you need test equipment that's looking 24/7 to stay on top of the patient's health. You need someone in your facility to become a deep diver into switch configurations. I've worked with various switch vendors, Arista, Cisco, incredibly sharp people. They understand it. They're right there. They'll team view right in. But you can't count on that for the entire life cycle of your facility. Someone in your facility, more than someone, a whole bunch of someones, need to become an expert in switch configuration. That way they know what's right, what's wrong, what to do, how to avoid problems, how to configure things. They need to be on top of it. Because what we're really doing here with test equipment in the world we're going to, nobody has canned solutions to anything as far as fixing a problem. You need to have intelligent conversation with a system integrator and a vendor. Here's what it looks like when it's working, this part of the network. Over here, after this black box, it's not working. What do we need to do with this vendor, this black box? How do we fix this? How you do that is sharing screens, doing stream captures, having a dialogue, try this, try that, and you can see, did it help or did it hurt? Try to configure your PTP system, then try to break it. Precision time protocol is the biggest challenge in the industry, totally underestimated in the early days. Everybody thought, oh, we're just like doing black burst with packets. No, it's far beyond that. It's bi-directional timing. Configure your system. Every creative way you can think of messing up your PTP. Try it. Does it recover? Does it ever recover? How quickly does it recover? How do we figure out how to avoid that from happening? So pull cords, disconnect GPS antennas, whatever you can do to upset the system, try it and make sure things work. Video engineers, IT engineers, we could spend a lot of time here, but what I'm seeing, most facilities that are doing well, we'll take the video engineers, I'll work with the IT people, we're going to meet in the middle, everybody will be happy, everybody will cross-pollinate. Businesses that aren't doing so well say, how do we get rid of some expenses? Well, those video fossils over there, they're obsolete. We'll bring in all our sharp IT people and life will be good. That works till the first legacy problem. They start bringing people back in as consultants or part-time or whatever. But there's a big difference. The biggest challenge, as I said, is IT engineers. If they have no broadcast experience, they do not understand smoothness. They do not. They have no reason to. And that's the biggest challenge. IT engineers, once again, if they have any finance background, they understand, because finance industry is like television. There is no downtime. Every second counts. Things have to happen quick, and you have to avoid problems and fix them as fast as possible. So that's some advice there. But anyway, you need tools. You need to be able to look at quality of service, quality of experience, pick up the pace here. What we're looking at, the early days, 2022-6 was taking SDI, chopping it into packets. That's the HANK, the VANK, the embedded audio, the ancillary data, you name it. Clip it, put it in the packet, and send it along. It's a beautiful thing. Everything arrives on the other end, hopefully the same way it was taken apart. But the problem is, in a facility where you're doing audio and video sweetening and you're adding closed captioning, you're constantly de-embedding and re-embedding the 2022-6. So that's why we go to 2022-10, which you see there at the bottom. Because what it takes SDI and tears it to shreds. Video goes one direction, timing goes another direction, ancillary data goes another direction, your audio goes wherever it needs to go. So that's the approach there with 2022 moving to 2110 world that pretty much everybody has gone to. We have AES for audio. We'll talk about IEEE 1588 and SMPTE 2059 precision time protocol. The -7 is redundancy for seamless switching. Let's keep moving here. The -10 is system timing. -20 is your video. 21 is buffer modeling, a timing model. You need virtual buffers so you know what you're sending, how smooth it is, so you don't overflow and underflow. Your audio, your -3031 for audio, ancillary data, that has its own path. And 50 is where we're going with the redundant feeds. As far as the basics of SMPTE 2110, it struck me early on, we finally get rid of blanking. It's gone. We don't need to send blanking because everything gets torn to shreds, so just active video and blanking doesn't matter anymore. Why is this a big deal? Because you can have any raster size, any resolution, any format you can dream of, and then some, because it doesn't matter. You're disconnected from the actual picture size meaning anything. So forklift upgrades, if you go from 4K to 6K or 8K or whatever is next, or you want to go to something like 2110 can be 32K by 32K. I said, why in the world do you need resolution like 32K? And the person said, how about a ribbon around the stadium, 32K wide? That makes sense. I go, well, there you go. So it's a lot of flexibility. Incorrect timing in composite video. I got involved in video in high school in the 70s. Really, I started in the early 60s. I was a remote control for my dad, so I would be the one that would adjust the horizontal and the vertical. And then we got color TV in the late 60s, and I was the color and the tint guy. So anyway, that's how I got involved in television, by being the remote control for my dad. But really what PTP is all about, which I could spend a whole hour just on PTP, which you want me to, we can do that at some point. We have a master clock, locked GPS, which is highly recommended, blasting out packets to the network. And once again, it's all about stability. So you send 2 sync messages. This determines how much latency there is in the network, and is there any propagation instabilities. It timestamps them when they're sent, they're looked at when they're received, and it tells the receiving device what time it is. Then the received device sends a request back saying, here's what time I think it is, and this goes back and forth, bouncing packets back and forth until it nulls out. This should happen in 5 seconds or less. You hook up a device, properly configured, tested before, hook it up to a network, it should lock the PTP in 5 seconds or less. If it doesn't, it probably won't lock in a whole lot more than 5 seconds. But that's the benchmark. That's what it should be as far as a device locking up to PTP. But it's messages sent back and forth in the network until it dampens out, and then you have a stable network. Here's the Prism, the MPI. This is a waveform monitor. The next generation does SDI, does black burst and tri-level. Also, it does IP. 2110, 2022-6-7. It does precision time protocol. So it's for hybrid facility. It can be very basic as far as operator, waveform, audio, picture. The good stuff, it can be very high-end productions. There's a lot of really unique tools for getting HDR correct, which means it should convert nicely to SDR, which is the biggest challenge I see with HDR, is getting it to look good in SDR. So we have tools for that. And then it gets down to the rocket science level of SDI as far as eye patterns and jitter analysis. Also the deep rocket science of IP 2110 and your PTP. And we'll get into that. But it has a lot of range, is very scalable with options. There's a back panel view. You can see the various IP and SDI connections. And there's an MPX. MPI, as I showed you before, I for integrated screen. MPX needs external screen. There is no internal screen. Functionality is the same except for the screen, but what you get is the ability to have speakers. You can have 2 speakers there, do confidence level monitoring of your audio. So this, once again, is a hybrid device, IP, SDI, and it's a platform decision. We also have, under a lot of requests from our OB trucks, they like screen real estate for their shaders. And what we have now is a dual display. So you have an MPI, for example, on the left, the shoebox we talked about earlier, and you can have a secondary display. So you can have 5 tiles. It gives you more real estate because shaders like to see picture, waveform, vector, audio, whatever. They have a lot of choices for how they configure things. So what we're seeing here, as far as an extended display with the MPX on top there, you can have 2 touch panels. And once again, these are touch panels. They're also, you can control them with a keyboard and a mouse. And they have full functionality with the remote GUI. Use Chrome or your favorite internet browser, and then you can see what's happening, control it as if you're sitting there. So with the pandemic situation that we have, a really nice thing to have. So you can actually remote, you can do your production remotely, you can do your troubleshooting remotely, so it has full functionality remotely. And then on the bottom, what we can see is the MPI with a dual screen. So you have the shoebox on the left and a short depth screen on the right. So basically showing you the same thing again. Let's keep moving here. All different formats, wide color gamut, HDR. We do all the logs, C-log, S-log. So we do a lot of PQ, HLG. And there's some more shots of the hardware just to give you an idea as far as weight and depth. Trying to keep the depth as short as possible because racks are getting shallower, not deeper. Inspect 2110 Pro. This just came out. We intended to make a big splash at NAB, and I'll show you a demo of this. this is a great complement with the Prism, which a Prism is good for operations and your basic troubleshooting and deep engineering. But what the Inspect 2110 probe does, it gives you an overall view of what's happening in the entire facility. It can look at multiple feeds, your primary and your backup, to see how healthy they are. So an operator view on your master control or your network control center, you can see what's actually happening on all your feeds. Green is good, red is bad. Then if something turns red, you click on it and keep drilling down, and you can actually jump from the Inspect 2110 probe, which is unique to the industry, a big feature here. You can then go right to a Prism and start drilling from that point. So it's a lot of flexibility there. It's a hardware platform, and you can see it's a COTS platform. I want to get to the demo here. It comes with 5 programs. A program is actually 2 streams, so you can add 1 program at a time. Changeover units, because even in the world of IP, we're still going to have hybrid facilities. So you still need a changeover unit for your analog blackburst and tri-level, because you don't need a changeover for PTP. That's part of the Grandmaster clock algorithm, which a cool 20-minute presentation just on that. But the fact is, you need a signal generator locked to GPS for both your blackburst and tri-level. And there's all your options. And keep moving here. I want to get to the demo. Okay, let's jump out of this, and hopefully I'll have no trouble sharing my screen with... Okay, let's go to the remote demo, and if everything's still working here, we shall see a remote demo. All right, let's see what I can do here. There we go, share screen, there the button went. Share screen, okay, share screen 2. Can you see my screen of the Inspect 2110 probe with the red and the green thumbnails? Can you see that?
Yes, Carl, we can see it.
All right, thank you. It was good to have that confirmation. We're starting at the highest level, the Inspect 2110 probe. Green is good, red is bad. Thumbnails are everybody's favorite. And keep moving here. You can see a compact view. If you can have many streams, so you want to compact it, you can see it that way. Or if you like a census, thumbs up or red. That's a quick way of seeing what's happening in your facility. And PTP status. This is important, like I said, because that's a very big challenge. What I like to look at is the Grandmaster ID. The MAC address is very important. So MAC addresses. For video people, we have to learn MAC addresses. Should be able to memorize them to see, oh, that's whatever vendor it is. That makes sense, because what you want to see here for Grandmaster for your PTP, if you go with an SPG 8000A, which I would highly recommend, you would see 0800. That's the MAC address ID for Tektronix and now Telestream. So the fact is, you want to make sure your Grandmaster is actually something it should be a Grandmaster. Because what can happen if you're not properly configured with PTP, a device that is not worthy of becoming a Grandmaster steps in and says, I'm in charge here. And if that's a Grandmaster that says it's an Arista switch or a Cisco switch, well, that's fine, but it's not worthy of being a Grandmaster. So improper configuration of PTP can actually allow a rogue device to take over the network. Everybody else stands down and lets this device run it, which is not locked to GPS and not designed to be a Grandmaster, but it has happened. Grandmaster changes, none. Always like to see that. Over here, as far as announce, sync rate, request rate, response rate, somewhere in the 4 to 8 times per second is what I want to see. If I see 0.5 times per second or 1 time per second, that's not good. That means I probably am looking at 1588, which is not worthy of running a network, but has happened. Some people configure it that way and it takes over. And you do not want to see these numbers like 50 or 100 times per second. That is what's known as a Band-Aid for a vendor's device that's not capable of following the PTP 2059 standard. And I've seen facilities actually running the entire facility out of spec at 50 to 100 times per second, because one device in the facility can't lock to the actual 4 to 8 times per second. That's a whole lot of traffic. That just causes problems as the network grows. All networks grow. You want to figure it out, which vendor, what device, which black box is non-compliant, and get the vendor to fix it, to relieve all that traffic on the network. Diagnostics, alarm log. Always a good way to see what's happening. So we look right in there. Green is good. You can scroll and scroll, scroll, and you can drill down and see what's happening if things are not happening as you think they should. Let's drill down a little further. And what we're seeing in the Spec 2110 probe are your attributes, as far as, once again, your source and destination IPs, primary, secondary video, your gigabits per second to see if that makes sense, your frame rate, see if that all makes sense, your SDPs, your session description protocol, which says this is header information that says here's what's in the stream. Does it match? Does it match the actual file to what the actual header to what's in the content? And does it match on the redundant streams? You can't have two streams of different formats, which has happened. So it's a good way to visualize what's happening. So all your flagging, as far as, it's a pretty deep analysis, even at the highest level. But what you can do then is drill into a prism. And let's look at, not that one, I want to look at the other one. Let's go to that one and look at a prism. Hopefully everything comes back up here, and there we go. All right, so basic video. So what we're looking at here is the prism, which I've drilled down into. And what we can see here is a picture. There's no audio right now, unfortunately, but I can see what's happening here as far as the waveform. I can see if there's any stuck bits, because I'm looking at a UHD feed, 3840 by 2160. And we can actually go up to 8K. So if anybody has interest in 8K, we're now doing 8K, which is pretty amazing. So a good way of seeing what's happening at a high level. Let's go to another preset here to show you what's happening at the IP layer. What I like to start with is IP status. Let's clear out some of the errors, see what happens here. Okay, so what we're looking at, I have 2 ports coming into the back of the prism. This prism is up in Boston. I'm outside of Washington, D.C. in Virginia. And what we see here is what's on my 2 ports, ports 1, port 2, as far as PTP, my video, my ancillary data, my audio. Well, there's no audio right now, but I have a -30 if there was. Bit rate, payload ID, and I can scroll to the right. Destination, source, your MAC addresses, domain numbers, any errors, your clock frequencies, and your markers, 59.9. Well, that's always good to see there. At the top here, this is showing a 25 gig interface with forward error correction, or you have no forward error correction. And what's showing you how much bandwidth is being consumed on 2 of those 25 gig ports. We have the blue bar right here. Let's drill down and look at, we have an IP generator. That's a nice thing to have. It's always good to have a known good source, and that's what Telestream specializes in for our instruments. Start with a known good source. If you have a problem, is it the feed coming to you, or is something being corrupted in your facility? If you put in a known good source and it's corrupted, well, you own the problem. If not, then you say, well, it's coming to me from somewhere, that I need to look into it. Okay, let's look at PTP timing. What we're looking at here, which is a very powerful tool, go full screen, is the crosshair in the middle, the X there, is actually your PTP for your house reference. That's a nice thing to see. Then we have the NTSC, your black burst, is over top of that, because right now they're locked as solid as they can possibly be locked. In a facility where this is drifting, it means your black burst and your PTP are not locked together. They're not correlated. They're drifting, which is not a good thing. So you can actually visualize what's happening at the PTP layer. IP session, let's go here. Start with layer 1. You need to look at all your layers in an IP stack to see what's happening, what's not happening. Looking at layer 1, we have a signal. Layer 2, we have a lock. Then layer 2, do I have any oversized, undersized packets? Any errors? Any bit error rate? Any CRC errors? Good way to see the health of the network. If a network's not healthy, layer 2 is probably being corrupted by buffer overflow and underflow. Then moving up the ISO stack to layer 3, we have our IP addresses. Layer 4 is port identification. Layer 5, moving closer to the actual video essence. Once again, there's 5994, so I'm actually looking at video. Audio, pretty much the same thing. Your layer 3, layer 4, layer 5. Same for data, because I'm actually doing closed captioning, it looks like. PTP, very important look here. We're locked. My UTC time, master phase lag, you're allowed 1 nanosecond, and we're doing very well here down the, you're one microsecond, excuse me. We're in the nanosecond range, so life is good. My master ID, always good to see the 0800. Steps removed. This shows how much hardware is between your PTP source and where you're doing your measurement. Less is better. You don't want to have 15 steps in a facility. Less is better. So your elegant design, that's a very important aspect to keep in mind. Your domain, we're looking at 2059, which is a wonderful thing. And as far as I ever come back and do a in-depth PTP presentation, all of these numbers are very important as far as making sure your grandmaster failover parameters are set correctly. That way, the device that's worthy is running the network. If it's not, it steps aside, and the next qualified device comes over. At the bottom, you can see your 4 to 8 messages per second. NMOS. Don't have an NMOS server hooked up at the lab outside of Boston yet, but when we do, we'll see an SDP file come in here. That way you can actually see what's happening. NMOS is going to get us to the wonderful day where plug and play actually exists in the world of 2110. Right now, it requires a giant spreadsheet of IP addresses, port destination, multicast join addresses, and all that stuff. If you get it right, congratulations. You get it wrong, no good. So NMOS is going to be able to do more of a plug-and-play approach. We're ready for it. The industry is kind of dragging their feet, but there's reasons for that, but we'll get into it. PTP graphs. I like to visualize things. We have a graph here, and we have min, max, and mean. The tighter the numbers are here, the smoother your network. So it's very handy for seeing a big picture. IP stats. Let's do another preset, preload things here. And IP graphs. How I can look at 2 paths. I have my primary and my backup, and looking for smoothness. Min, max, and mean, very important. Cmax, video receive buffer. What this is buffer modeling at a switch level, also at a device level. Because television, we want low latency. The trouble with low latency is it requires small buffers, a smaller gas tank. You're constantly filling it and draining it, a leaky bucket, for example. So we want to make sure our buffer modeling is being maintained and not going into overflow or underflow. I like histograms. Let's see what's going on here. Well, we have a very tight histogram. Loading, let's see what happens. Okay, we're still good here. What we're showing is the fact of a histogram is telling me how much deviation there is in this network. And as far as a tight bell curve is what you want. What you don't want to see is a flattened bell curve, because a flattened bell curve is telling you the network's getting more congested, there's more instability. What you want to totally avoid, which I've seen in some facilities that were finger pointing rampantly, is you have a bell curve that's squashed with outliers between the left and the right popping up. That's what's known as overflow and underflow corruption issues. So you want to avoid a bell curve that's flat. So once again, test equipment is all about visualizing the invisible, the abstraction layers that we're dealing with for audio, video, your SDI, and definitely into the world of IP. Because without these tools, you're guessing. You can only reboot your way to success so often, and then you're just wasting time. So anyway, I hope this was of value. Covered a lot here. If you want me to come back and get deeper into anything, we can schedule that. I'd be glad to do that. I'd like some honest feedback here. At any time during my presentation, did anyone go online to look at their retirement portfolio? Okay, anyway. So anyway, thank you very much. I'll hand it back over to Mark. And any questions? Anybody want to reach out to me via email? I'm always available. And I said I will be getting more involved with the Philly section because January 1st, I will be your SMPTE Eastern Region Governor. Once again, thank you, folks at SBE. Thank you for joining this. And hopefully I gave you some insight of where we're going.
Thank you, Karl. Great presentation. Appreciate it. So at this point, we're going to open up the floor for any questions. You can do that verbally by opening up your mic and unmuting it, or put them in the chat, and we'll do it. So I'll wait a couple of minutes here to see if anybody has any questions.
I got a question at Burke here.
Yes.
Hey, one thing that always you talk about 4 to 8 times sampling per second for the PTP timing.
Yes.
How do you get frame accurate when you're only sampling, a 4 to 8 times per second versus, how do you get frame accurate?
How do you get frame accurate? That's a very good question. I mean, with analog, we're down to the picosecond practically, and then with SDI, we went to pixel accuracy. Here we're aligning packets. There's roughly 4 packets per line. So you're really trying, it's amazing how it works. I had people ask me before, but 4 to 8 times per second, you're actually aligning packets, 4 packets per line for HD, and it works. I mean, the whole idea is packet stability. And then once the oscillator, the big flywheel gets locked, it seems to work quite well. It's about as much of an intelligent answer as I can get because it's packet alignment is what you're doing. Okay, that's a good question. Anyone else? Once again, you want to email me or reach out to me on LinkedIn, that works for me. I look forward to someday actually presenting in person. Nothing like the feedback from a live crowd.
No, we look forward to, and maybe in the spring we're talking with Karl about possibly doing another presentation. Hopefully, that point we might be able to engage with some more in-person and face-to-face communication.
Yep, and since I have a captive audience here for the next few seconds, what we're trying to work on with me becoming Eastern Region Governor is trying to figure out how to help sections have like an all-day event. I mean, the Washington, D.C. have been doing it for 20 years. Washington, D.C. in the last 15, we've been doing Bits by the Bay. It's a 2-day conference. So if there's any interest in that, it's a lot of work, but you have several presenters and you have to have a venue lined up and all that stuff, registration set up. But that would be something I'd be willing to work with you because I'm trying to get other, because I'm responsible for the whole Northeast, trying to figure out how we can make that happen if there's any interest. But this section appears fairly healthy with a lot of active people, so maybe it's something to consider.
I think that's a great idea. And I want to add to that, I think we should reach out to the universities in the area to try and work with them to create something that's not just for us, but for the university to bring the students on board and get them interested and have them understand a little bit more about SMPTE and about the industry and how broad and how wide this industry is.
What we just did last week with DC SMPTE is we have a STEM event. We reach out to high schools and community colleges and universities in the Washington, D.C. area. And what we did is we had a Zoom session, which I've never done before. It actually has breakout rooms, and it worked great. We have everybody meet in the main lobby, and then we say, okay, there's some breakout rooms you can sign up for. What I did was careers in the industry that are not that obvious. So I had did 2 sessions. I had about 15 to 20 students in each one, and I thought I brought to light careers they never thought existed in the industry. So the breakout room functionality of Zoom was impressive. And then at the end of the session, you get a countdown 2 minutes until the session is over. At 0 time, the breakout room goes away. Everybody's back in the lobby. We discuss things, and then we go back to another session of breakout rooms, and it worked flawlessly. We had 70 or 80 people, I believe, for the event. So Zoom with the STEM event, great way to reach out to universities. And what it was all about was having the old timers share how to get in the industry, what kind of jobs there, I mean, from archiving to the engineering, all different aspects, and to have them realize that where you start in the industry has no bearing on where you're going to go to next, just to keep your eyes open, your head up. Once again, have to have a talent, people like you can just move and move and move and grow. And your career will take you places you probably never dreamed about, because in reality, where you're going to end up in 20 years from now doesn't even exist today. So you can be the one that creates the future in many aspects. So something to consider for universities. We can, I was not fully involved with the setup of it, but the Zoom approach worked really well. And
add to that, I've worked with some things like that, Karl, and they do work really well when you're having large groups and smaller groups on there. So it's an excellent idea. And something we'll be talking about at our managers meeting coming up, and how to do something to get more people involved. So
I'm here to help.
yeah, thank you very much. Okay, it's 1:05 right now. I'm going to start to wrap this up. Anybody else have a quick question before we wrap it up? Okay. Well, go ahead. Sorry, Karl. Go ahead.
No, I'm standing by.
Okay. So thank you to everyone from SBE and SMPTE for joining today's webinar. I appreciate it. If you have any questions, Karl, can you put your email in the chat so everybody has that? And feel free also to email Phyllis SMPTE at outlook.com, and we'll respond with any questions and respond with any emails you may need, Karl's or mine. So the slides, we will have a video up online on YouTube that in a couple of days here, once we process it and put our little logo on it, and everything else should be available on there. It shows that a lot of people like to watch these videos, and come back to them. So we'll be doing it. We'll put it up. It'll be on our YouTube channel, and hopefully it'll be up on the SMPTE website as well. So again, thanks, Karl, for all your time and effort putting this together. It's a great presentation. I appreciate it.
Yep, I just put my email on the chat. It's karl.kuhn@telestream.net.
And I just put Phyllis SMPTE email address. So again, thanks to everyone. Enjoy the rest of your day and enjoy the weekend. Take care.